Hello, everyone. This is the second half lecture of Chapter 2, all about research. So, so far, we have talked about the basic steps of research. Just to review, we have discussed the 4 different types of research. We discussed what variables are and different aspects of variables. And then we discussed methodology, most specifically independent variable, dependent variable, experimental group, and control group. We're now going to start talking about data collection and data analysis, and then we'll talk some about ethics in research. So here we go. If you remember, we talked about our Fred's therapy for depression study. And if you remember, we took 100 moderately depressed people. We randomly assigned them to 2 groups. One is the experimental group that gets the independent variable or Fred's therapy. The other group is the control group that does not get Fred's therapy. We gave them the Beck Depression Inventory before we started this to show that both groups were in fact moderately depressed on average, and that their scores were just about the same, so that we can use the concept of comparison at a later time. We then re-administered the Beck Depression Inventory, which results, in this case, define the dependent variable, and we see that the research shows that Fred's therapy created a much greater change in the subjects in diminishing the level of depression, as did no treatment. Very simple study, and we're going to continue on this motif. Okay? Let's talk a little bit about data collection, which is really about using the independent variable. In this case, we get our independent variable, or the results, or in other words, we actually use the name of the test that we use as the symbol for the independent variable. In this case, it was the Beck Depression Inventory. We tend to need to have some protections in data collection. And that brings to the forefront the need for either a single blind study or a double blind study. And we also need to take into account the concept of a placebo and the placebo effect. So here we go. What is a single blind study and why do we need it? Well, if the subjects know that they are in either the experimental group or the control group, if they have knowledge of that fact, will it affect how the subjects behave in the study? Well, if you know you're in the control group, therefore you're going to assume that no change is going to occur, and does that permit your mind to play with you, and even if you do feel better, convince you that you don't, because you're in the group that's not supposed to get better? Well, yes. And if you know you're in the experimental group, is it possible that believing that you are receiving a treatment that is going to help you, is it possible that that could influence the way you respond? Well, yes, it could. And we have good research that suggests that when subjects know which treatment condition they're in this case, we have the treatment condition of receiving the therapy, the dependent variable, or not receiving the dependent variable is the other treatment condition. If people know which treatment condition they're in, they tend to behave accordingly. So for that reason, we don't let people know which treatment condition they're in. That means that sometimes we need to use a little bit of deception. And in this case, we would have used deception. We would have simply let the control group people know that they were in a waiting group. And that's how we would have justified not giving them treatment immediately. We would eventually give them treatment after a couple weeks. And we are dealing with moderate depression, and so that way we're not at risk of somebody getting much worse without the treatment process. So that's something we would have done. That, in that case, would have been a single blind study. The term single blind means that the subjects in the study do not know which treatment condition they're in. That is the definition of a single blind study. Now, sometimes we need more than that. Is it possible that if the researcher knows which subjects are in which group, that the research might judge the improvement of the subjects differently because of their bias, their prejudice towards wanting the therapy to work? Well, we actually know from research that that's the case also. We've done many pieces of research where the subjects knew who was in which group, and the purpose of the study was to determine if those who do ratings of subjects would respond in such a way that shows favor because of knowledge of the information. So in this case, instead of using the Beck Depression Inventory, let's say we used the Zung Depression Inventory, Z-U-N-G. It's a real depression inventory, but it's administered a little differently. The Beck Depression Inventory is simply a 21-item paper pencil test. Now, there's no way to bias the collection of the data on that from the researcher's perspective. You give them the piece of paper, they fill it out, now you've got the data. And if the subjects don't know which treatment condition they're in, then there's no bias. But the Zung Depression Inventory is administered differently than the Beck Depression Inventory. In this case, the Zung Depression Inventory is a structured questionnaire that is given by the researcher. The researcher reads the questions, and then the subject responds to those questions with orally, and then the researcher, with both the use of the test and the use of clinical experience, then rates the subject on that item. Now, if the experimenter who's getting those answers from the subject knows whether or not the subject is in the experimental or the control group, then knowing that information could affect them. So what Fred would have done is he would have taken his 100 subjects and probably brought in 5 or 10 different friends of his who were psychologists and asked them to interview 10, 20 different people, but would not let them know who was in the control group or who was in the experimental group, would simply administer the Zung Depression Inventory to them. Now, we know that the Zung Depression Inventory is actually a little bit more accurate than the Beck Depression Inventory in determining levels of depression, mostly because you've got the addition of clinical experience from the clinicians who are giving the test. You have their experience, and then you also have the information coming from the subject also. So that being the case, we would then do what is called a double-blind study. A double-blind study means neither subjects nor researcher knows which treatment condition the subjects are in. Therefore, both the subjects and the researcher are blind. Therefore, a double-blind study. Blind to which treatment condition the subjects are in. Therefore, there's no bias. So we have to use these little tricks, because if we don't, then we risk losing all that good data and all that good methodology in a bad research process. Now, let's, got to erase here. Let's take a look at the whole concept of the placebo and the placebo effect. So I'm going to erase all this now. And what is a placebo? A placebo is a fake treatment. It's a treatment that doesn't have any medicinal benefit. What it does have is the potential belief by the subject that it could help the subject. Well, do placebos have an effect on subjects? Well, yes, they do. They have quite a bit of effect, actually. Let's say we are putting together a study for the newest and bestest medicine for migraines. Okay? You'd get 100 migraine sufferers, and then you would divide them into two groups, just like we did with Fred's therapy for depression. We would give 50 of them a real pill. We would give 50 of them a sugar pill, but we would not let them know which pill they got. So therefore, for sure, you've got at least a single blind study going. It would probably be a good idea to have this be a double-blind study also, because it would not be good for the researcher who is interviewing the migraine patient, the subject in the study, to know whether they are getting the real pill or whether they're getting the placebo, because that would then affect the researcher's judgment of whether or not that person's migraine is as bad or not so bad, etc. So it would probably be a good double-blind study also. That being the case, we end up with an interesting concept. What's going to happen to the people who take the placebo? It's nothing but a sugar pill. It doesn't have any medicinal benefit. Are they going to get better? Well, research tells us that people who take the placebo get a little better. So there is a placebo effect. That is the effect that the placebo pill causes. Now, here's what we're going to do. We're going to make a little graph here. And over here, we'll have the amount of pain relief. And we'll have the placebo and the medication. Probably what we'd see is that the placebo created some benefit for the subjects just because they believed that they would get a little better. Whereas the people who actually got the real medication would not only get as better as the placebo people got, but instead they got even more better because of the real medication. So what you're going to see is something like this. Here is the benefit of the placebo. They showed some pain relief. Well, the medication itself is going to have that same effect just because the people believed it was going to help. But then there's all the more effect up here that the individual receives because of the actual medication itself. Now, do we tell people, oh, that's just a placebo, you're not really feeling any better, that'll wear off in a little while? Oh, heavens no, we don't do that at all. When people come into my office and I'm treating them for depression, and I have an initial session with them, and all I do is just gather some information, get to know them, and often at the end of the first session I'll hear, oh, that feels so much better. It felt so good to get all that off my chest, off my shoulders. I'm feeling quite a bit better. Do you think I'm going to tell them, well, what we really did today was just kind of a placebo? I didn't really do anything psychotherapeutically that was going to help you at all. So in a day or so, you'll feel just as crappy as you did before. Well, I'm not going to tell them that. I'm going to take the placebo, the simple effect that they're meeting, that they have some hope. And then I'm also going to get the additional benefit of psychotherapeutic interventions that occur over the course of time. So you get the benefit from the placebo, as it were, the placebo effect, and you get the treatment effect on top of that. So that's where the placebo comes in. It's pretty tough to create a placebo for psychotherapy because there's so many characteristics of psychotherapy that just simply involve interpersonal interaction. And you can't take those things away in a placebo kind of fashion. But every once in a while there's a piece of research that does a pretty good job of that, but not very often. So, there's data collection. Data collection is pretty important stuff. All right. Now, we have to take that data we've collected, that we've carefully collected, and now we're going to analyze it. Now, if you look at your study guide, you'll see that there are two basic types of statistics. There are descriptive statistics and inferential statistics. What are descriptive statistics? Well, by golly, it means that they are statistics that describe our subjects. And what are we talking about here? Well, we're talking about measures of central tendency. Every one of you has learned these measures of central tendency before. Mean, median, mode. Okay? What's the mean? Well, everybody knows what the mean is. It's the average. You add up all the scores, you divide it by the number of scores, you got the average. Does that tell you a whole lot if you're just given the mean of a group of subjects? It doesn't tell you much at all. It doesn't even tell you the range unless you see the raw data. But it does tell you something. It's sort of a middle score, but it's not exactly a middle score. Then you have the median. The median is the central score. Now, when I say the central score, this is what I mean. It means that you have 21 subjects in your study, let's say. Okay? Let's say that you have 21 subjects in your study. Which subject's score will be the median? Well, if you have number 21 up here, then you'd have number 11 right in the middle, and you'd have 10 below 11 and 10 above 11. Your median score would be whatever score the person got that's number 11 in rank order. So maybe 3 people got a 7, 2 people got an 8, 9 people got or 2 people got a 9, and 3 people got a 10. And then 11 was all on its own, and then it's 12 up to 21. Well, 11 would be your median score because it was the 11th score in order from bottom to top. That's the median. And, sometimes more than one person gets the median score. And then there's some math that figures out what the exact median score is. But that being the case, now we talk about the mode. The mode is the most frequently occurring score. So let's say 5 people all got a score of 11. If that's the case, and no other scores were there more than 5 of, that means the mode is 11, because 5 people got that score. So it's the most frequently occurring score. Now, we're going to take a simple look at the bell-shaped curve. Everybody's learned about the bell-shaped curve. And we're going to talk a lot about the bell-shaped curve in this class because it tells us a whole lot of information about our subjects. Now, a bell-shaped curve is divided up. It's divided up, first of all, in half with the mean. That little X with the line over the top is the symbol for the mean. Okay? And then we also have what are called standard deviations. And these are our dividers that further divide the halves. And it goes further and further out if it needs to. We usually only take a look at 2 standard deviations below and 2 standard deviations above the mean. That's usually all we look at. But these are standard deviations. And by standard and deviation, we mean standard or fixed. Deviations meaning different from. So these are fixed differences from the mean. So they're the same on both sides. Okay? And it divides up the percentages of people. Now, the theory of the bell-shaped curve is that this line down below means nobody fits down below the line, and nobody fits above the curve. Well, that means everybody fits between the curve and the line. Therefore, certain percentages of people fit in different sections of the bell-shaped curve. Now, that being the case, we then take a look at mean, median, and mode. If the bell-shaped curve is a pretty little bell-shaped curve, and it's all nice and symmetrical and even all around on both sides, that means that the mean, median, and mode are about the exact same score. If that's not the case, then you end up with a weird shaped curve. So, if the mean and the median are significantly different, let's say the median score is quite low, then you're going to end up with a curve that is called a skewed curve. That would look something like this. Because apparently more people are scoring very low and less people are scoring high. And it's not nice and even like the bell-shaped curve. Instead, it leans to one side. In this case, it would mean people are scoring low. Lots of people. And fewer people are scoring in the middle or high on whatever measure you're using. So if the mean and the median are significantly different, and if the mean, median, and mode are significantly different, then for sure you're going to have a skewed curve. But if the mean, median, and mode are about the same, then you get a nice symmetrical bell-shaped curve. And we use that information to tell us about our subjects, to define how they're scoring, where they find themselves in this entire process. Okay, those are the measures of central tendency. Now we're going to talk about another descriptive statistic, and this is called the correlation. Now, what does the word correlation mean? Well, the word in and of itself does not mean that two variables have to be the same. That's what a lot of people think. When two variables are the same, then they correlate. But that's not the truth. In fact, they could be very different and correlate. And we look at the term correlation in a number of different ways. Now, let's take a look at correlation from a number of different perspectives. I'm going to provide you two variables here. X and Y. I know this is sounding like math, but it's okay. And you have subject number 1, and then you have all the way down to subject number 100. Now, variable X is a male's height. Variable Y is a subject's or an individual's shoe size. Now, what correlation really means is that there is a relationship between the two variables. What does that mean? A relationship between the two variables. What that means is, if there is a relationship between two variables, it means that if you know the one variable, you then can, if you know the score of one variable, then you can do a pretty good job of predicting the score of the other variable for that subject. It's not going to be perfect, but it can be pretty high. Now, with height and shoe size of adult males, do you think that we could do a pretty good job of predicting what someone's height is if we know their shoe size? Or do you think we could do a pretty good job of knowing someone's shoe size if we know their height? No, it's not going to be perfect, because I know tall people with not too big a shoe size. I also know short people with great big feet, but that's very rare. So if we took a graph, and on one side we had height, and on the other side we have shoe size, and we have 0 feet up to 8 feet for height, and we have a shoe size of 0, which doesn't exist, and that goes up to shoe size of 30. Now, believe it or not, there are people out there with shoe size close to 30. The biggest shoe size ever in the NBA, and it wasn't Shaq, was a size 27. I wear a size 9. That means that person had shoes 3 times the size of mine. That's great big feet. So, here you have it. Height over here, shoe size down here. Now we can graph each individual. You know what this graph looks like. If Shaq is about 7 feet 2 inches tall, he'd be about right there. And he actually has size 22 feet. He'd be about right there. So we go across and there's Shaq. Now me, I'm 5'10", or at least I used to be before I started to shrink, because I'm old. So you go down, well, this is going to be 4 feet. This is going to be about 5 feet. This is going to be almost 6 feet right there. So about right there is me. and I have a size 9 feet, which would be about right there. So I'm right there. And let's say we have somebody else in our class who is about 6 feet 4 inches tall. That means they'd be a little bit higher than me here, and they'd probably have size 14 feet, maybe 13. So they'd be right up here somewhere. That person would be about right there. Now, what are we starting to see? We're starting to see a distribution of scores. Is it in a straight line? No, it's not in a straight line, because you're never going to get a perfect straight line. But what are you going to get? Well, what you're going to get is a grouping of scores that's going to look something like this. It's going to be a tight grouping in an ellipse shape if we have 100 people, and it's going to be kind of like that. Because we can do a pretty good job of predicting what a person's height is from shoe size and what a person's shoe size is from height, because they are correlated, they are related to each other. And we have this line that goes right through the middle. This is called the regression line, or the line of best fit. You remember the fun little math that you did? Y equals mx plus b. That's the regression equation. And you can determine what the line of best fit is by taking all these scores and running it through that formula. Okay. Well, what would this be? It means there's a relationship between the two variables. On the other hand, if we took hair color and intelligence score, is there going to be a relationship? Well, actually, there's not. I know that sounds like a blonde joke, but if we took those two variables over here, it was hair color from light up to dark, and down here we had IQ from 0 up to 140, which is a pretty high IQ score. We would have a distribution that looks like this. And it would be in the shape of a great big fat zero, because there's no correlation between those two variables. You can't determine a person's IQ based on the color of their hair, nor can you determine a person's hair color based on their IQ. So those two variables do not have a relationship. They're not grouped tight together. Okay? So when we talk about correlation, we talk about relationship. Now, there are some other aspects of the correlation that I need you to know. Number one, we've already discussed the definition of a correlation, meaning the relationship between two possible variables. Do we want there to be a relationship in our Fred's Therapy for Depression study between number of sessions of psychotherapy and level of depression? Well, yes, we want there to be a relationship. We want to know that if you get more psychotherapy sessions, that the depression will drop. We want there to be that relationship. If there is, then we get to write home and say, hey, Fred's therapy works. But we have to look at that a little bit more in a little bit, because we're still just talking about the correlation. Now, I want you to know the definition of a correlation. I want you to know what a strong versus a weak correlation is. Now, the correlation has a formula. The guy who came up with the formula for the correlation, he was studying intelligence. And he wanted to know what variables predicted intelligence in an individual, and was trying to figure that out. And so he had to come up with a formula to determine how well he could do that. And the formula for a correlation gives us a number. So you have two variables with 100 subjects, for example, and you're measuring them on two variables, and you're trying to see how well can you predict one variable if you know the other variable. And you'll get a number. That number will be between -1 and +1, including -1, with 0 in the middle. So correlations always come out as a fraction. Well, not always. You can actually have an actual -1 or an actual +1. Now, I'm going to caution you right now. -1 isn't bad, and +1 isn't good. We'll talk about that in just a minute. For a correlation to be a strong correlation, it means that your correlation coefficient, or the number you get from your formula from the correlation, is far away from 0 in either direction. So if this is a 0.70 correlation, and over here you have a 0.87 correlation, the negative 0.87 is a stronger correlation than the positive 0.70. Okay? It means that you can predict better. The further away from 0, the better you can predict. So if on a test, I was to ask you, which of the following correlation coefficients predicts the strongest correlation between two variables, and I were to give you A, B, C, and D, and A was positive 0.13, and B was negative 0.86, and C was positive 1.32, and D was negative 0.67. Which one of these would be the strongest correlation? Well, many of you all of a sudden said positive 1.32. Well, no, that is not a correlation coefficient. It's not between -1 and +1. Which is the one that's furthest away from 0 from the remaining 3? Well, that's going to be negative 0.86. Okay? So the further away from 0, the stronger the correlation. The closer to 0, the weaker the correlation. Now, what do positive and negative mean? Well, this is real simple. And I don't want you to complicate this in your head. It's a very simple concept. A positive correlation means that the variables increase or decrease together. Now, what's that mean? Well, let's take a look at height and shoe size. If you pick subject number 23, and subject number 23 is 6 feet 6 inches tall, okay, that means that person's pretty tall. What do you expect their shoe size to be? High, like a 15 or a 16. Okay? So if they go up together or down together, that is a positive correlation. Going down together means, let's say we have somebody who's 5'4", an adult male. Well, his shoe size is probably going to be something like an 8 or a 7.5. That means those two variables go down together. So if they go up together or down together, then it is a positive correlation. If they go in opposite directions, it's a negative correlation. And again, positive doesn't mean good and negative doesn't mean bad. What would a negative correlation be? Well, a negative correlation would be poverty level versus education level. If a person's education level is high, what do you expect their poverty level to be? Low. If a person's education level is low, what do you expect their poverty level to be? Relatively high. That it would be a negative correlation. Okay? Now, it's only negative in one direction. Low education, high poverty. But in the other way, it's a good thing. High education, low poverty. So it doesn't determine good and bad. It just determines in which direction the variables go in comparison to each other. So a negative correlation, the variables go in opposite directions. A positive correlation, they go in the same direction. Okay? That's what a correlation means. So we've talked about the definition of a correlation, a relationship between two variables, which means you can predict one from the other. Number two, a strong correlation further away from zero. And number three, a positive versus negative correlation, whether they increase or decrease together or oppositely. Okay? So that's what I want you to know about correlations. Now, the next thing on your study guide is inferential statistics. What is an inferential statistic? Well, if descriptive statistics describe our subjects, we can use descriptive statistics on naturalistic observation, on case studies, on surveys, and in experiments. But inferential statistics infer or predict cause and effect. And what's the only type of research that can infer cause and effect? Well, if you remember from the previous lecture, that's the experiment. So only the experiment can infer cause and effect. Remember why? Because the cause is the independent variable, the thing that we're putting into the system to try to make something change. And the effect is the dependent variable, our measurement of whether or not the independent variable made a change. So cause and effect, experiment, independent variable, dependent variable. Okay? Now, that permits us to draw conclusions. We're not going to talk a whole bunch about inferential statistics because getting into it is very complex. But in our silly little study, our Fred's Therapy for Depression study, we would do a statistical analysis called a t-test. A t-test compares any two groups on one variable. And what's the one variable we're comparing our two groups on? Our experimental group got the therapy. Our control group did not get the therapy. Therefore, we're comparing the two groups' outcomes with each other through a t-test. Now, you can complicate a study as much as you'd like. You can do an f-test and an f-test with covariance, and you can do a chi-square, and you can do all sorts of different analyses. But they all are the same thing, cause and effect, if it's an inferential statistic. Okay? So that's what I want you to know about inferential statistics. There's also that whole concept of confidence levels. What's a confidence level? It means that before you even start your research, you decide how confident you are that your treatment, Fred's therapy, is going to make depression go down. Well, most of the time in psychological research, we use a confidence level that's called a 0.05 confidence level. What does that mean? That means we are 95% sure that any change that we see in our experimental group that gets the treatment compared to the control group is because of Fred's Therapy for Depression. And we think that we can be 95% sure. Would you be okay with getting Fred's Therapy for Depression if you were depressed and you were told that it was 95% likely that you would experience some significant change? Well, yeah, most people would say yes. We can do a 0.01 confidence level. That means you're 99% sure. You can go to a 0.10 confidence level, which says you're 90% sure. Well, like I said, generally in psychology, we choose the 0.05 level. And that means that our scores that we get on our Beck Depression Inventory after our experimental group gets our Fred's Therapy for Depression, when all that occurs, the change that happened to our experimental group is so much bigger than any change we saw in our control group that we can say we got a number from our t-test that is above the number of the 0.05 level. That means it's higher than what we expected. If it's higher, then we're happy. If it's lower, we got to start all over again and do something different. Maybe even change the therapy. Who knows? But that is what research looks like in psychology. Now, 2 definitions. Statistical significance. When you read in a study that statistical significance has been achieved, what that means is, hang on one second. I'm lecturing, I can't stop.
What?
I can't pause my lecture. I have to lecture.
Oh, I just don't remember how to put in an amount on that. Oh, I don't know.
Sorry about that, folks. Here at the office and had to deal with a little bit of business. So statistical significance means that the individual okay, let me catch my train of thought again here. Statistical significance means that our research gave us numbers that say our outcomes were above the level we predicted they would be, meaning that 0.05 or 95% sure that the change that occurred was because of the independent variable or treatment rather than just some weird fluctuation of probability. And that can happen. Every once in a blue moon, we see a study that tells us something real significant. We think it's great, but then we find out it's really not. That it was some weird fluctuation of probability. It happens once in a blue moon, but it doesn't happen very often. Okay? That's why we don't just do most important studies once. We do them twice. This is called replication. You do the study twice, and that way you got 95% sure that the cause of the change was your treatment. And if you get that twice with 2 different sets of subjects, then you can be pretty darn sure that your research was good research. Now, that being the case, it's important that we do replication. That means repeating a study to see if we get similar results. Okay, now, last thing I'm going to talk about just very briefly, ethics. In human research, what's the most important ethic? Informed, voluntary consent. That means people need to know what they're getting into and that you're not going to lie to them in such a way that it's going to hurt anybody. Every once in a while, we have to deceive people. In our study, we would have deceived people. In other words, they didn't know whether they were in the experimental group or the control group, but we can't let them know. But it's not going to hurt anybody. So as long as we're able to show we're not going to hurt anybody and we do a little bit of deceit, that's okay. But sometimes it does hurt people. The Milgram studies, many of you have heard of the Milgram studies. This is when Stanley Milgram took people into a room and told them to shock people if they spelled words wrong. Well, they really weren't shocking anybody. And the people that were being shocked were just graduate students who were playing a role. But these people kept pushing the button on the machine that would shock somebody sitting on the other side of the table from them. Well, what they were trying to do was determine why people are willing to do horrible things to other people. Like, this was shortly after the Second World War, they were trying to figure out how did the Holocaust happen? And what they were trying to determine was, does the influence of authority cause people to do more bad things than a lack of influence of authority? And they found out that it was true. But then when they were all done, they sat down with the subjects who thought they were actually research assistants and told them how sadistic they'd been. Well, they didn't use those words, but in essence, that's what they told them. And some of the people who were fooled into participating in this research actually got quite depressed. And the researchers had to give them lots of psychotherapy and help them out because they felt pretty crummy about all that. You can't do that to people. They have to be informed enough to be able to choose to participate in a functional way, and it has to be truly voluntary. So informed, voluntary consent, and then of course not doing anything that's going to hurt anybody. The other piece is animal research. In animal research, now some of you, and I am not going to argue this point with anybody, are going to say nobody should do animal research, and that may be absolutely true, or it may not be. Now I would ask one question. If 10 chimpanzees had to be test subjects and ended up being euthanized, that means they ended up being killed as part of the study. If 10 chimpanzees had to lose their lives in order to come up with a treatment for an illness that was a mortal illness, but they found a treatment because of it that could cure the illness, and it cured your child, you might think a little differently about whether or not that research was okay. Or you still may say that we shouldn't do animal research. And you know, both sides have some good arguments. But with animal research, diminished suffering. That means you have to make it so the animal doesn't hurt. And believe me, there are a lot of horrible pieces of research where the animal hurts. I want you to look up, darn it, what's his name? Seligman, Seligman, and his dog and cat shocking studies, where they actually put dogs and cats into boxes with metal gratings at the bottom and shocked them to try to prove some things. They could have figured out a better way to do that without hurting those dogs and cats the way they did. So look up that study so you see what I'm talking about. There shouldn't be any severe pain caused to the subjects. Now, that's just a basic review of ethics. Take a look at all that. I will your test for Chapter 2 is already available. I don't remember what date it is that it has to be done by. But remember, you have a writing assignment, a one-page writing assignment. You have discussion posts and responses. And you have a quiz that you have to take for Chapter 2. I will have another lecture up for Chapter 3 for Friday. That lecture, Chapter 3 is Biological Bases of Behavior. We'll be talking about the brain and the neuron and all sorts of other stuff. So, get done with Chapter 2 here over the next few days, and then start into Chapter 3. And like I said, I'll have the first lecture for you available on Friday, and I'll try to have the second lecture available for you on Saturday. And then next week, we'll start into Chapter 5. We are skipping Chapter 4. You don't have to read Chapter 4. We will skip to Chapter 5. Okay? It's been wonderful to be here with all of you. I still hate this not in-person stuff, and I wish we were face-to-face, but such is life. Thanks a lot. We'll talk to you soon, and have a good week. Bye-bye now.